Sometimes you just get told about the problem. So if you're like me and you're, say, a DBA at heart, how many products have the letters SQL in them? Besides SQL Server, there's SQL Server Report Services and Analysis Services. They even have Notification Services. Anything that says SQL, somebody come to you and say, hey, I need your help. I have a problem with SQL Server Report Services. And you look at it and go, yeah, so that's not really, aren't you the DBA? So sometimes you get told to fix problems that aren't even your problem to begin with. So that's an important thing to understand. You might be told to fix a problem regarding the size of the data and design and things of that nature, and it's really not even anything that you have experience doing. So, a little bit more about me. You can reach out to me at SQLRockstar@thomaslarrock.com. I sometimes blog, I sometimes tweet. I work for Confio Software. We have a little table out here, makers of Ignite 8, Ignite VM. You can find me on LinkedIn. I'm a SQL Server MVP and SQL Server Microsoft Certified Master in SQL Server 2008. Enough about me. So, today's agenda, what's the problem? So, the problem. Your database has a design. Fair statement? Anybody disagree? Just like a ship, a car has a design, right? Starship Enterprise. I think somebody told me the image I grabbed is the pizza cutter. Starship Enterprise. It's awesome. It was the only one that like fit in that little area. Okay. Data goes in, rarely falls off. True? How many people here have an actual data archiving strategy? I mean, it goes away and leaves disk. Nobody, right? Because just in case you need it. Again, you're a hoarder. You don't even know it. Just in case. What if we recover from tape? No, if I need it, it better be there, right? So you lug it around. Databases are mixed use. How many people here believe they have an instance that is dedicated OLTP? Dedicated transaction, no, because somebody needs to run a report against whatever you're loading in there. Almost every instance in here, I bet, is mixed use. Mixed use. Data professionals are often asked to convert what is essentially a pickup truck, right? That's what that mixed use thing is. It has to be everything to everybody. It's a utility. You're asked to convert that pickup truck into a Ferrari, right? Flat out. You were just told, I need things to be faster now. You know that's a pickup truck, right? If you said to somebody, you know what, can you pimp my ride? Can you take that pickup truck and make a Ferrari? They go, no, it doesn't work that way. Logically, most people wouldn't ask for that. Illogically, people come to you with this database and say, yeah, performance is really bad. I know what it's like right now, but we need it to be incredibly faster. Just go make it happen. So here's what I've come across in all of my years of experience. If you want great database performance, it starts with great database design. You don't get a Ferrari by sketching out a pickup truck to start with. So, how database designs fail. Many designs do not account for size. I think that's a fair statement. Anybody want to disagree? No? Feel free to disagree. I'm never always, sometimes right. Row count might be considered. Honestly. Right? Sometimes they get considered. A lot of times people just say, all right, I got orders, order details, I got customers, I got employees, I got all this, your standard database design thing. How often does somebody say, okay, and we're going to have 1 billion rows? Very rare. Very rare. Even people who do Scrum projects, a lot of times they're agile, right? A lot of times they're getting together, they're just building out the code prototype, and in dev they run it against like 10 rows. They say, hey, everything looks great, and all of a sudden that code makes its way to production against 10 billion rows, and it doesn't run the same anymore. Well, where's the problem? The problem is that you didn't think about the actual size of those row counts. How many rows are you going to be working with? But what about inside the rows? Inside those rows, those are your columns. And how those columns get defined is often overlooked. Second thought, what is that? So Karen, what's a social security number?
Mine?
No, not yours. What is it? What's it get defined as?
Depends.
Yeah. How many people here define social security number as, say, 9-digit number? Anybody? You do? It's okay. Say yes. No. Say yes. It's a 9-digit number?
No, yes.
It is? Okay. But how about for Karen in Canada? Do you have something equivalent?
I have a SIN number.
You have a ZEN number?
SIN
number.
A SIN
And is it defined as an integer?
No, because it has letters.
Mm-hmm. Because it has letters. Right. So quite often it gets, and would that be an N char for you? Do you need Unicode for that?
No,
No.
it's old.
It's old. So why do data types matter? All right. This thing's bothering me now. I'll move it down there. See if that gets any better. So what is a database? It's this big icon, right? A database is essentially a logical container for data on disk that can be spread between multiple file groups. So a database is a logical structure that's made up of one or more file groups on disk, right? And what we recognize as rows here have columns defined, okay? So logically, as a database, you think of things in terms of a table structure. A table is really just for you humans to understand how the data is actually logically grouped. The database itself doesn't really care. It doesn't really know what a table is, just structures data by that, right? So these columns, this defines what is called the row length. Now, remember we talked about these file groups. SQL Server, most database systems, store the data in pages or some type of logical grouping on disk. For SQL Server, it's called a page. How big is a page inside SQL Server? 8K, right? So, 8K page inside SQL Server. This is our row length. Ideally, do you want your row length to equal 8K? No? Why not?
It will depend on the data.
I'm sorry?
Like my row will be like depend on my database design.
Yep.
We have something like long and text or something like
Okay.
that. So it may extend more than like the row size. Like 8K.
Okay, so what would be a good row size then?
Something evenly divisible by
Depends.
What? Something what?
something evenly divisible by
Evenly divisible by 8K?
Well, I
That would
mean,
imply the row would be
yeah,
bigger.
right. I mean,
Other way around,
Right,
maybe?
yeah.
So how big should your rows be? As big as they need to be is not a bad answer. But you want to understand that the more, the least, if it's equal to 8K, if your row equals 8K, how many rows are you going to fit in the page? One. If your row is equal to 4K, how many rows do you get in the page? 2. Yes, I know it's early. If your row is 1K, how many do you fit in the page? And every time SQL Server has to go to disk, one I/O is one page, right?
no.
So the many more rows you can fit onto a page, the less work SQL Server has to do. Yes, sir.
Isn't an IO an extent?
I'm sorry, an I/O and extent.
An extent.
An extent is
64.
64.
Okay.
No, I don't think so. I think one logical I/O is one page. Can you pull back an extent as one I/O? That's a great question. It's not
I don't
my
know. I always heard
understanding.
that whenever it reads from disk, it reads things in extents.
It might. Okay, so it comes back with 8 pages. And the difference would be how many rows do you want on the 8 pages that
Right.
comes back. Okay.
I was actually
Yeah.
asking you the question.
Yeah, I know you are, and I actually don't know.
Okay.
I've always thought of it as one. Anybody want to find out? Chris might know. Chris, one logical I/O, is it one page or is it an extent? Yeah, see, he doesn't know.
When SQL Server is talking about 8K, but I think the question was more when it actually goes to disk, what's happening.
Yeah,
So an I/O from the operating system standpoint might be 60.
Maybe more.
right. That's a great question. I'll have
And then
to
some of
add
them
that.
might just throw it out.
Yeah, it is a good question. But anyway, the concept here is keeping the row lengths less than 8K keeping the row lengths to be what you need them to be and not just going big, which is what we're going to see happens later. So, keeping that in mind, now let's think about this. What is an integer? What is an integer? Now, for me, I'm a math major. Integer means they're numbers, positive and negative, they include 0, all right, and no fractions. That is what an integer means. What does an integer mean for somebody who does computer science or database designer? This is probably more likely to be the definition for an integer, right? And requires 4 bytes of storage. That's an important fact, isn't it? An integer requires 4 bytes of storage. And it has a range of numbers. So this is me, the math major. This is database designer. Says, yeah, integer, yeah, and 4 bytes of storage. Do you see any possible disconnect? If you don't, you will. What do you think?
You have the size limit,
You got a size limit.
and you may decide you don't need a whole integer to be a primary key.
Unless you're a math major that's been asked to design a database, and you say, oh yeah, things are just numbers, I'll just use integer, right? But you won't even know about this. You won't even think to yourself, oh, I'm going from minus 2 billion to positive 2 billion, and it requires 4 bytes of storage. All you think is, I need a number. I need a number for something that you don't really need numbers for, maybe like zip codes. Postal codes for my Canadian friends, right? But of course, those have letters. Anyway, the point being is that you're going to find people have different understandings of what certain terms mean, like the word integer. So here's an example. Look at your Visual Studio defaults. If you go into Visual Studio and you say you want to create a table, okay? This is what you see. By default, it gives you a couple of column 1, column 2. Great names, by the way. At least they spelled it all out, not just call. Defined as an integer. Defined as an integer. Okay. Do you need an integer for the column? You don't know yet, right? They're throwing a default out there for you. Okay. So, check out what they do for a procedure. If you go into Visual Studio and you go to create a procedure, they actually give you 2 parameters as an example, and they also define those as integers. It's very interesting. Okay? At least they match. At least they all match. This is actually, you're going to find that this might be an issue later on. A mismatch is likely because you're going to pass in what you think is an integer, and it might get compared to, say, varchar. And we'll see an example of that later. So despite Visual Studio giving you an effort to make things match, you can still end up with a mismatch later on. Okay. Check out Management Studio defaults. This is awesome. First call. Not column 1, first call. Love that. Check out this. nchar 10. Do I need nchar 10? All right. So here's the question. With Visual Studio? No, I'll say when .NET first came out. How many people are old enough to remember that? It's okay. When .NET first came out and you went to create a table inside Visual Studio for a .NET application, do you remember what the default data type was for a column in the table? Anybody? Yeah, nchar 10, you are so close.
Okay.
Who said nvarchar 50? Who? Somebody. Own up to it. You're going to win a book. Oh, you said varchar 50? You're close enough. Win a book. nvarchar 50, by default, was what you got assigned. Did you need nvarchar 50? How many people here created an application table and stuff, and you loaded data, and you said, yeah, nvarchar 50 sounds good? Okay, one person. And nobody else did? You're lying, because I have been the administrator for these systems, and I see 20 columns defined as nvarchar 50, and I know how old the app is and who built it. Okay? And it isn't just this one guy here. We've all done it, right? Because you didn't know. You're like, yeah, maybe I need it, maybe I don't. What's the harm? What's the big deal? So, I'm pressing, but nothing's happening. nchar 10. Check out, if you go into Management Studio and you decide to create a procedure, it actually, the 2 parameters it gives you int. It doesn't even match what it gives you for a default in the table. That's even worse. That's even worse, I'm sorry. That's even worse than ending up with a bad mismatch later on as things get passed in. I mean, you're starting with nchar 10 and it says int right there. That's crazy. That's crazy. All right, date example. How many different date times, data types are there in SQL Server 2012? The answer is not 6. So guess what the answer is? Is the answer less than 6? It can't. It has to be even more than 6. So if I told you that go set it to be date type. Data type, find the right date one. You got 9 options to choose from. These are the 6 more common ones. Love the datetime 2. Wait, do I need datetime or datetime 2? What does datetime 2 mean? Right? Length in bytes. Date itself is 3. Small date time is 4. Time 5. Datetime 2 can be 6, 7, or 8. Datetime is 8. Datetime offset is 10. Which one do you need? You're storing date. You're storing date, storing time. Date and time, just time. Wait, what? Could they make this more confusing for you? You don't even know what one do most people end up using? Daytime. What one do people actually need? Yeah.
How old is date?
What's the range on date?
No, just like
When did it come
we
in?
had daytime for so long, right?
Well, daytime, I actually tell people they usually only need small daytime.
Yeah.
You say date because most people probably don't even need the time aspect of it, but most of the time, I see things defined as daytime, and the range of dates are within the past couple of years. And I say, okay, did you need precision down to 100 millisecond? Did you need that precision? And did you really need to be able to go back to, I don't know, what, year 1000 or whatever? Did you need this range of dates? And the answer is no. And you say, great, then we should really consider small. No, we don't want to make any changes. No, of course you don't.
So why don't Microsoft make the default as a small datetime instead of?
Actually, Microsoft makes defaults in their tools as integers, so they don't even bother with this. This is like advanced. You got to dive into this. This becomes the default because to people, they say, I need daytime.
Yeah.
And other systems, especially if you do cross-platform, I'm not sure every system has the concept of a small daytime.
Yeah.
It might have a different name, but almost every system has something called daytime. Have you gotten to timestamp yet? What's timestamp for SQL Server?
Not
Not anything to do with actual time. But what is it for Oracle? It's actually something for time.
And
So-
all the other DBMS.
Right. So if you could try to go between, so now we get into what ANSI standards are. All right, so that's a different thing altogether. This is just the example to show you how confusing it can be. Even if you have an idea of what the idea that data types matter, you end up here and you go, whoa, what is it we do need? Right? So a lot of times, yes, sir, what can I help you with, buddy? Nothing? You sure? Oh, you did?
You want to know SQL?
Yeah, you want to listen to me now. You want to sit in the back? Aunt Karen's in the back. You're going to sit in the front row?
Yeah.
Good for you.
Good. Welcome.
That's my son, yes. You've heard this talk before. You could probably give this talk by now. Okay. So where's this? I swear I'm clicking and it doesn't want to work now.
You notice?
Okay. So where's this going to hurt you? 3 areas: disk space, memory space, and performance. So data type pain number 1, disk space. Disk is cheap, yes? Yes? Disk cheap? No.
Not really.
Not really. It depends. Great. But there are hidden costs with disk, even if you do say it's cheap. More storage will be longer maintenance, longer database backups, longer tape backups. Has anybody here hit the point where your tape backups now run longer than 24 hours? If you haven't, that's a great day in your career coming. When the tape backups try to kick off again and they haven't finished from yesterday. And people are calling you and then they say, can you just get rid of some data to make things a little bit smaller? No, I can't. I've been trying for years, but we have to keep it around. I can't just go truncate tables. Well, I can, so I'm not going to. So that's your first data type pain. Most are unaware of how many times that tiny piece of data gets stored. For example, if you have a very wide clustering key, right? Not just wide in terms of columns, but data types as well, that gets added to each non-clustered index. Yes? It's part of the key. So it gets spread to each and every one. So imagine if you have a cluster key, and I don't know, anybody here come across a table of 18 non-cluster indexes on top of that cluster? Yeah? Not yet. If you haven't, another good day in your career coming. Because they're there, and when you find them, you start to think to yourself, you go, oh my God, that's a lot of extra overhead I have. So that results in some bad things. So those extra bytes get read from disk into the SQL Server buffer cache, because that's how SQL Server works. Your extra logical I/O is needed to return your query result. And what about the index? I'm sorry, data type pain number 2, memory space. So how SQL Server works is it has to read things from disk into its memory space. So those extra bytes get read. So if I have to read many more pages or extents off a disk, it has to add up space. It takes space inside the buffer pool. And the extra logical I/O is needed to return those query results. And what about the indexes? It's the same thing. They drag around the extra logical I/O as well. So let's look at a quick example. Let's see. Below Surface Pro, what do I want? Let's do this.
question.
You have a question, sir?
No.
You sure?
Yeah.
Okay. So let's. You can't see this?
Ooh, I do have a question.
Why can't you see? All right, hold on. Why? Create a blank database. All right. Yes, connect. I'm going to create a table. Define right there. Define a date as small date time. We'll create a non-cluster index on that table. Then I'm going to populate it, 20,000 rows, just insert some values. Okay, take a couple of seconds. Then I'm going to run just a very simple query, right? And I'll do statistics IO on and off. Everybody get familiar with that? If you're not, you should be. And we'll run this. And in the messages part, what is the logical IO? 55. 55. Just like it says up here. It becomes 55 logical reads just to pull back that amount. If I look at the space used, because that's one of the reasons we got here, I see 3192, 1320, so it all matches up. So this is the size of my database. That's how much is reserved on disk, size of the data, size of my indexes, and what's unused. Yes, sir?
There's a couple of donuts outside.
Okay, that's not really a question.
Can I have one?
Oh, that's a question.
Sure.
It's not really relevant for the talk, though. So if you'd like a donut outside, that's what you're asking? What kind do you want?
We'll see.
No? Pick one, quickly, right now.
I do know.
All right, you can have one. Go on.
Everything. Let's go on.
So we're going to do this all over again. We're going to drop that database, create a new test one, create a table. This time I'm going to go date time. Let's go big. Create a non-cluster index, populate with 20,000 rows. Then we're going to run that same exact query, but this time against the date time. And it's going to come back and tell me 65 logical reads, just like it says right there. So what's the difference between 65 and 55? Don't just say 10. And 3384. Come on now. What's the difference between 65 and 85? I'm sorry, 65 and 55. You know,
More space used.
It's 10 and over 50. It's a 20% performance hit. Sure, the result came back in, 1 second or less, right? But it's a 20% performance hit. On a very simple example. Look at the size. The size reserved was 3192 to 33. Again, not that big a deal, right? Oh, you wanted to bring it in here? Did you bring enough for everyone? All right, so reserved, you see, again, what's the difference here in percentage and all that? You can see there's more data reserved, that's just reserved on disk, right? It's actually not even being used. You got more unused right now than anything else. It's part of that data file. How are you going to end up getting rid of that eventually? How are you going to get back? How are you going to reclaim that unused space at some point in your life?
We should do it by shrink DB.
Yeah, somebody's going to run a shrink database in order to get that space back.
But that's not.
Auto shrink. Auto shrink. There's your friend. All right. Can I get right back to where I was? Oh yeah, if I do this now, I get right back to where I was. This isn't one of works. Okay. So I just have to sit here. So data type pane number 3. How am I doing on time, by the way?
45 minutes.
Oh, wonderful. And I'm on slide 43. Excellent. So, extra logical I/O. That was the example we just gave. Data type pane number 3 is performance. Data type mismatch, right? So you're going to end up with data types defined as one thing, but you're going to query thinking it might be something else. These are data type mismatch. This results in an implicit conversion. Now, the optimizer knows that this is bad. Anybody here not running SQL 2012 yet? You're still using 2008. I don't think the optimizer is going to show you this for me. 2012 is where I believe it starts displaying this warning icon. I think in 2008 you can get the details for the implicit conversion, but the icon isn't there. I'm not
You
sure.
mean in the query plan?
Yeah, I wonder. I'll show you what the warning looks like. But the icon shows up in 2012, which is really cool. The optimizer knows implicit conversion was bad and displays a warning for you in SQL 2012. But guess what? The optimizer knows it's bad. It's still up to you to make the change. All right? The optimizer doesn't just rewrite your query and say, oh, yeah, I'll just redesign this in order to make things faster. Although the optimizer, trust me, knows that things would be faster. But it doesn't do that for you. So there's an issue with code generators. Anybody here still only running, say, ADO.NET 3.5? It's fairly old at this point. But there was a major issue with that particular version. So if you are still running that, I leave it up there. But code generators like to just sort of spit out code, but don't necessarily care so much about data types. You can see a lot of implicit conversions through code that's being generated by Link and Hibernate, Entity Framework, those types of things. Anybody here using these tools? Anybody here not necessarily using them, but feeling the effects of those tools being used in your shop? Yes? Yes. Chris, look at Chris. Yeah. So ADO.NET actually, 3.5, I say supposedly fixed. There was a service pack. So if you are running ADO.NET 3.5, there was a service pack put together years ago that if you apply it in any later version of .NET framework, this should be fixed for you. So don't worry about it. Well, let's look at an example. Oops, I didn't want to do that. Let's use AdventureWorks. Yes, connect. So inside of AdventureWorks 2012, we have this little table. Come on down. And it's called Human Resources Employee. And what we're going to do here is I'm going to include the actual execution plan. And we're going to run both of these. And did I return statistics IO on? So I'm going to run two queries. So I should tell you this. Inside the table, this is how the national ID number is defined. It's an NVAR 15. So even Karen can use it up in Canada. So I'm going to run two queries. They're both valid. I can run it and assume it's an integer. I could just say, yeah, it's an integer. Go ahead, run this where national ID number is equal to that. And I can also run it as a string. SQL Server is going to allow both of these. It's not going to care. The difference is going to be this. The difference ends up being this. 6 logical reads to 4 logical reads. So the first one, running as an integer, okay, took me 6 logical I/O to satisfy that query. If I add 2 little single ticks, and I say it's actually a bar chart, or it's a string compared to the n-bar chart, it doesn't have to do the conversion. In the execution plans, you see this. Oh, come on. I don't know why you did that. In the execution plans, it's displayed easily. You can see there's a little warning icon here. This guy has this little warning. No warning down here where I passed it in as a string. There's a warning up here. It's the same key lookup index scan up here. Oh, sorry. Down here where it knew it was string index seek, right? Because it had to do the conversion, it forced an index scan up here. And SQL Server even tells me. Now, if I want to see that warning, is I have to come over here. And that's where I could see that. What this says is type conversion, may affect seek plan and query plan choice. So that's right in the show plan XML. So I'm not sure if in 2008 if that warning gets tracked, but I know in 2012 not only is it tracked, but it displays a little warning icon for you. So if you're running and you see that little warning icon, right click, go to properties, go down, examine what it's telling you. That's SQL Server saying that, I don't want to say it's sick, it's got a little back of its throat. Right? That's what it's saying. It's like, yeah, I did this for you, but you know, it was a little more painful than it had to be. Now, I had once upon a time a really good question because I gave this example using just that one row, 6 to 4. What's the difference between 6 logical I/O and 4? I'll just say 2. 50%. So I created a table and I said, well, since that table had everything you need, I did the same example But we're going to run it against this table DBOM that I created, just to show you that for more than one row, what we end up with. So how many rows come back? 209, 101. So I populated the table, same exact data, I just allowed multiple entries, right? So 100 rows come back, 644 to 320. Again, it's twice as much, right? All right. You have another question? Please don't let me about donuts.
It's not.
Okay,
Can I
but
just rephrase something?
yeah, sure. At least he raised his hand.
It's a good kid.
Yeah. So 644 as an integer. Again, it comes back in just 1 second. What's the big deal? 644 logical IOs. You're forcing SQL Server to do more work there than you really had to do. Very simple things. Defines nvarchar, query as if it's a string, not an integer. But yeah, a lot of code generators might just say, oh yeah, or people just pass something in, or you're using these tools, and you say, oh, it's defined as an integer. You look at the values and say, yeah, those look like integers, and you never really know what data type you're talking about. That's how code ends up being written that ends up with implicit conversions and poor performance. I'm now tied to my chair because my clicker has stopped working, but that's all right. Solutions. So we've talked about the pains quite a bit. Now let's talk about some solutions. First step in any solution, admit you have a problem, right? First thing, admit. First sign is when OLAP queries interfere with OLT processing. This is probably true for everybody in the room already. If you don't know it yet, you certainly will. Most systems, in my experience, a majority, I believe, are legacy systems, especially in my industry, financial services. They were built essentially to handle transactions, lots of high volume transactions even. And at some point over time, somebody said, you know what I need is I need a report off that data. And that's when it starts becoming mixed use. Now, when those report queries start interfering with data actually being inserted, that's when you have a problem. As soon as somebody says, I don't care that you're trying to enter that data, I need this report to run, you've got a problem. And this will happen sooner rather than later, actually, but it'll happen. If it hasn't happened yet, it will. For SQL Server, that typically shows itself with high levels of locking and blocking. Okay? Another sign is plan cache bloat. Anybody here not familiar with plan cache bloat? Yes? No? You're not? So plan cache bloat is essentially your plan cache stores, if you're not familiar with this, so SQL Server will store a plan in a cache in an area of memory. So the next time another statement that comes along that is going to end up with a similar plan, it says, oh, instead of compiling and getting a new one, I'll just use that one. However, if you have a lot of single-use plans, like say from Entity Framework, and everything becomes its own query, your plan cache will fill up with a lot of plans that only get used once. Okay? So what you end up happening, you can go into the plan cache, and in 2008 and above, you can do this optimized for ad hoc workloads, which means it doesn't store the full plan, it only stores a stub the first time, so less memory. But believe it or not, that's just a Band-Aid, right? Because those little stubs can add up as well, especially if you flood the engine with a lot of these little plans. So that's another warning sign where you know you have a problem. You have a lot of queries coming in, and it's likely due to things like implicit conversions or just the nature of how the dynamic SQL is being created. So you end up with a problem that you can fix. Yeah.
How long is that stored?
Until restart, until it gets aged out. So as soon as SQL Server says, I need more, I need an extra space in my plan cache and I have nothing left, it finds a plan that hasn't been used in the longest amount of time. It says, I eject you, and I put the new one in. So, and there's formulas, it's dynamic actually, and depending on the version of SQL Server, your plan cache can only be a certain size relative to the other amount of memory you have.
Okay.
So at some point, SQL Server says, my plan cache is full, and I got to get rid of some, and it'll start ejecting.
So it's basically dynamic. We have no control over it.
You have control over the memory, but you can't say, make my plan cache 1 gig and fix it. But you can have an idea of how big within there. Like I said, there's a formula inside this white paper by Greg Love where he says, okay, if I have 16 gigs of RAM, X% for the first so many gigs, and then after that. All right, so you can figure out how big roughly it should be. Then what you can do is you can query inside some DMVs, and you can say, well, how big are the areas of my memory right now? And then you can match up and say, is my plan cache what I expect to see within a certain range? Because you might find that your plan cache is getting pressure from other areas. SQL Server actually started ejecting plans if it needs to steal memory for other things too. So that'd actually be pretty cool now that I think of it. Because if I know how much RAM I have and I know how much, roughly how big my plan cache should be, then I could actually every now and then query and just make sure my plan cache is about the right
Or
size.
just flush it out.
You can flush out manually. I'm not sure I'd recommend that because then every plan has to come back in and get compiled again. But your initial question was, how long does it keep it? It'll keep it forever. It'll keep it for as long as it can, is what the answer is. But at some point, it may get rid of it.
And the similar form, is it one store procedure have only one plan?
Does one SQL Server, one store procedure have one plan?
Yeah.
Ideally. So plan.
Because I have a developer that writing a deep statement and they have a very similar like say query, and that really causes performance issue.
Yeah. So you have SQL handles and plan handles. So one's at the statement level, one's at the larger plan. So you could have. You can find statements that have similar plan handles, right? So the short answer is that actually no. You can actually end up at points in time where you have two statements tied to one. The long of it is this, is that you can go into, what you really want to do is you want to look at queries inside the plan that have similar hash. So there's a query plan hash that you can go by and you can group. And what you're going to find for a query plan hash is those are queries that differ by literal strings only. So it's one way for you to go in and tune. You can say, all right, I see I have 27 different statements that are very similar, but they differ by variables getting passed in. So you can group by that. Does that help?
Yeah.
Thanks. So solutions. These are the solutions I've come across. We got 7 here. I'll run through these. Some of these are going to work for you today. Some are going to be things that are kind of a long-term solution. So the first is finding duplicate, unused, misused indexes. So you want to reduce your extra I/O. One easy way to do that is removing duplicate indexes. Anybody here use the Database Engine Tuning Advisor? No. Good for you. Anybody here come across an index that starts with _DTA? No? People, come on. Nobody here has come across a table with 27 indexes and 17 of them start with _DTA? Yes, of course you have. So, one thing that might be a good idea for you to do is to go in and look at, say, indexes that are defined as duplicates or unused or misused, as I put them. You can actually find both of these. What defines a duplicate index? There are scripts out there. I have one where you can find, basically, SQL Server allows you to create an index that is the exact same as any other index. Okay, I can create and say, non-cluster index on columns A, B, and C. The only thing that has to differ is the name, the object name itself. Other than that, I could have as many, 999 indexes that are the exact same. Yes?
How do you determine if it's necessary about to get?
I'll get to that. Yep. Great question. No, good question. No, great question because I have a slide for it. It's right here.
Why they create so many indexes at the very beginning anyway? So
Why do they? Because people believe indexes lead to better performance no matter what. Right, but they don't understand the implication of what I call all the DUIs, the delete, update, and inserts. If you have a lot of that activity, those extra indexes come with a lot of additional overhead. But for most people, they feel, oh, well, I need my query to run faster, and there's a missing index hint right here. Let me just go create that missing index. And they don't think about the other queries that might be hitting that table. So you can end up with a lot of extra indexes, some of which can be duplicate. They can. Unused and misused. You can go into the DMVs and you can say, you can find a query, an index that has many more writes than reads. It's a very simple formula. You can go into the index stats and you can say, this index right here has had 10,000 writes and 0 reads. What's the point of an index? Is it for writing or reading? Reading. So I would say that's a misused index. You can also go in and say, all right, I know the server was restarted a month ago. This index hasn't been used yet. So in 1 month, if I haven't used this index, is this something that is tied to a process that runs annually, quarterly, or, so that's what I would call as one being unused. So you can get that information right out of the DMVs. Test thoroughly. You can also examine the plan cache to find if indexes are used. Right? If you really want to, you could say, go into the plan cache, you could grab the text from all the statements that are inside there, and you could just simply filter and look for a particular index if you want it. You should understand that plan cache does reset on the service restart, or you can flush it manually. Actually, I think I have an example script. This is what one of these misused index scripts looks like. Where do I have it here? I say where something's greater than 10,000, order by reads. But I think I have this on my blog or somebody's blog. When the user updates less than one read, so that's an example of a script where you end up finding some misused indexes. So what you wanted to know, I wanted to tell you what the DMVs were. Is this partitions? Do I use a... I thought I had a function in here. DMDB index usage stats. There it is. I should highlight that. Right in the middle. DMDB index usage stats. So I would tell you, I would point you to that function and do a little bit of research, and you probably find scripts just like this. If you want, feel free to come see me afterwards. I can probably point you to some additional resources as well.
Okay.
Yep. Other solutions. Compression. Anybody here using compression?
Yeah.
You have a question, or are you using it?
No, we're using it.
Yay! 1. Anybody else? 2. Only 2. All right. So native compression has 2 steps. There's row compression and page compression, right? Row compression has to happen first, then page compression happens. Each table and index needs to have compression enabled. There is no magic button in SQL Server where you just compress the whole database. You have to go in and say, compress this table or compress this index. Each and every object. Kind of a pain, but you do get some benefits from that. Correct? I have an example. So if you're not using compression. All right. So let's make sure connected. Oh, that's the wrong one. Compression. So this I should already have my table in there for test compression. Let's see. So if I run this, what do I get back? 231,000 rows, logical read 7260. So we'll do this. I'll just write 7260 for now, so we remember. Now I'm going to turn on compression. So you notice the syntax here, just alter table, rebuild partition, data compression is equal to row. You get row, option, or none. So I'll turn on row compression. This is how long it takes. It didn't take much time at all for that particular data set. Sometimes it can take a while. Doesn't necessarily have to. Now I'll run this and we'll see. So what was the first one? It was 7260? 3978. Not bad. Less logical I/O, faster the query, right? There's overhead involved though. Where's the overhead? I'm shifting one workload from one to another. CPU.
More CPU.
It's more CPU, right, in order to pull this off. So keep that in mind, right? So the workload I've traded for was disk I/O and memory. I traded for CPU, but still, there's benefit, right? So now now that I've done row, I can do page. I could have done page to start with. If I had done page, SQL Server would have simply applied row compression first, then page compression. I'm doing them in steps. All right, run this. Now, what was that awesome? 3978. Okay, what's this one tell me? Comes back, 231,000 rows, 3894. What was the first one? 3978, 3894. I didn't get much on page. Why is that? Anyone?
We already have this.
Only 2 people here use compression, so I guess I'm only asking 2 people. Why would page compression not have given me more? Or were you expecting it to be more? Because I mean, I went from like 7,000, I cut it in half by going to row compression. Why didn't page compression give me another half?
That will depend on the data, like we have like.
Well, that's the answer. It depends on the data.
Yeah.
It depends on the data. So row compression takes the data types and it says I have extra white space, so let me get more rows onto a page for you. Page compression then takes all of those rows and it does what's called dictionary. And it says, okay, this line matches this line, so give that this, encrypt it as an A or something, right? But it's called dictionary compression, and that squeezes the page down even further. So if my data, depending on how my data is structured, row compression can get me there, but if the data between all these different rows doesn't match, in this case it doesn't, if I look at the results here, I see it was all based upon this text. These are different messages all the way down. So my data didn't really, there wasn't a lot of duplication of data to begin with within the rows. The rows are fairly unique from each other. So page compression actually didn't buy me that much. However, if I had gone and just done page compression to begin with, you would have gone from 72 to 38, and you would have thought page compression was the best thing ever. But it's not necessarily. It depends on the data. And to put it back, you simply go data compression none. Puts the table right back to where it was. And then you run your query again. And it comes back, and you're back to 7264. So it's one of those things that you can actually test fairly quickly and easily and put things right back to where they were. You can enable compression, see if it helps, if it does, doesn't, whatnot, understand the data, right? Test, and you can put things back. Doesn't really require a whole lot of overhead.
Is there any other downside to enabling page and row compression? Or should we just go blindly and compress all indexes and tables in every database?
So besides CPU, DUI, right? There's overhead for all the other activity that hit that. So if you are like doing an OLAP, you need to read data, and you want to get data off a disk and into memory and as quick as possible, then think compression. But if that object that you compress has a lot of write activity to it, don't think compression, because there's extra overhead. There's just overhead just for CPU to begin with. Just imagine every time you want to write into that, now you've got the extra overhead, right? So downside. So if you see a lot of write activity, I wouldn't recommend compression. Yeah.
Now, does it compress on every? Doesn't compress on every transaction, right? It compresses when the page fills, right?
When you initialize compression or
no.
Afterwards?
Afterwards.
But my page has been compressed. So let's just say I need to update data. Let's not even talk delete or insert. Let's just say I have a whole bunch of data in there and I have to update the values in the compressed data.
I'm talking about really inserts as things are
But in my mind, conceptually, I'm just saying I have to update the data. So there's overhead for me to get into, find it, and do the workload. So inserting, when I allocate a new page, I can't imagine that I would allocate a page that's already compressed, right? So yeah, the page has to be full, and then it gets compressed.
Yeah.
But I'm not sure if you're saying if that's a good thing or a bad thing.
No, I'm just kind of
wondering how it works.
Wondering how it works, and that it might not have the same impact as, say, like an index, where every transaction could affect the performance, right?
Yeah.
So in compression, I think it's a little bit different. It doesn't necessarily affect it in that same magnitude, if you will.
Well, and I would say that would make a lot of sense to me, considering that you have to compress each and every object. So if you've only compressed the table but not the indexes, right? But if you've compressed all your indexes and the table, then I think you're going to be asking for a lot of extra work on inserts and deletes that you probably don't want to do.
Right.
So that's probably
definitely on indexes, yeah, for sure.
Right. Okay. What are we already here? Oh wait, no. Column store is another. If you're not familiar with column store, it came out in SQL 2012. SQL 2012 wasn't a bad thing, except if you wanted to update the column store indexes, but you can do that now in SQL 2014. Column store is a little different than your native row page compression. It's what they call, well, they say dictionary compression, but they bought a tool, X Velocity. They bought some little company that was doing key value pair compression already. They put that technology right inside of the column store. So it works in segment and batches. It's really good if you have large volume of data that you can query in such a way. It's good, but it does require a lot of hand-holding. But getting it set up and doing it, if you're using just SQL 2012, it's a lot of hand-holding, because once you create that column store, you can't update the table. Okay? It kind of goes against the idea of an index, really, but you get locked and loaded, and that's it. You want to update that table? Not a problem. Drop your column store index, do your modifications, and then rebuild that index. Now, 2014 does allow for updatable column store indexes, but still, there's a lot of nuances with column stores about whether or not it's the right choice for you. It's a great option. When it works for you, it's great. I come across very few people that simply come to me and say, yeah, column store is the greatest thing ever. They like the idea of column store, let's put it that way. The concept and the idea is great. The practical use for it right now, I don't see it. Especially for 2012. A lot of people just look down and they say, that's a nice little toy, but I need something I can update without all these extra steps. Filtered indexes. Anybody here using filtered indexes? 2, 3. Some people. Good. Yay. More people. All right. Elliot, I'm going to ask you to hold the rest of your questions, please. I'm low on time.
I really do not know what time it is.
9:55. Okay. Filtered indexes. I'll get done in time. So if they're just like regular indexes, but they contain a where clause that allow for smaller footprints. So if I don't have to read the whole index, right? If I can just read the subset of the rows in order to satisfy the query, so less logical I/O for that. Archiving, partitioning. Some people have said that they did do some of that. It can be a viable partitioning can be a viable alternative to proper archiving. You familiar with partitioning of data? The classic example that they give where they partition things by a date, it allows the queries to only hit the partitions that are necessary so you don't have a full table scan. They can be easier to maintain. That doesn't necessarily mean easier to administer. And the quick example that they give right there with orders I grab from books online. So you can split things out, range for January down to December, put them all on separate file groups. So partitioning allows to get you some speed. So if the data still has to be on disk just in case somebody needs it, that's fine. So instead of months, you can think years. You can take partition by year, put things for a certain year range, people won't touch, that goes on really slow disk, and you tie the file group to that disk and you're done, right? That is a viable alternative to proper archiving. Archiving to me is the data falls off, goes somewhere. If I need it, I recover from tape. And there you go, I'll get your data for you. It'll take a day or two, but that should be good enough. I'm getting it from the archives. Most people aren't allowed that. They just, your business just tells you, no, if I need to run that query, I need it to run right now. All right? So you can think about partitioning. Verifying the data types are correct, always a good thing. You can compare the data type definition to your actual data. So you have a big int defined, but only small ints are being used. You can estimate savings. You can estimate the space as well as your logical I/O savings. Because it can be intrusive to alter these things, though, I wouldn't tell you to start making changes, especially if you have primary and foreign keys defined. You can't just go in and start saying, yeah, daytime, small daytime, stuff like that. There are, with anything, cost-benefit risks to think about. Here's one I put in here. If you check to make sure you're not running out. Anybody here using identity values? Nobody. One. Do you have them defined as, say, integers?
Yeah.
And do you check to make sure how many you have left?
Yes.
Smart man. I know lots of people who get the phone call in the middle of the night because that's the only time you get phone calls where something's failing because they've run out of values for the identity. And it's a hard lesson you learn once. So you run out, what do? Well, let me just reseed things so we can get things going again, but you need a longer term solution. Lots of times people end up saying, I'll just have to go big it now. But whoa, wouldn't it have been nice if they knew a month ahead of time? Because they were checking and they said, oh my God, I'm at 1.5 billion right now. I've only got a few 100,000 left or whatever. We're going to run out in 6 weeks. We need to take action now. All right, so you check now at least.
Yeah.
What do you do after you run out of big ins?
We haven't gotten there yet.
Yeah.
So it hasn't been an issue.
You're going to be retired by then. So verify data types. I actually have a little piece of code. This is an example of something I've had around for years, really. No. So I already ran this. So exist. Let me scroll down. So here's an example of a piece of code I put together that simply does exactly that. It goes in and it says grab from tables and columns and types and start doing some compares. I'll show you the first one. I compare tiny and small ints, and I just say, all right, grab it. If it's inside the value for big int, that's I'm sorry. How do I do this? The logic is if it's outside the values for integers, then it must be a big int. And if it wasn't, is it outside the value for small, then it must be integer, right? And so the logic just flows from there. So here's the deal. If I run this against AdventureWorks, oops, what? Okay. Oh, I don't know what I had first, but if I run this against AdventureWorks and I let it come back, what you end up with is, it says, okay, I have in sales order detail a unit price column defined as money, but I know that actually small money would work, and this is my estimated space savings for that, based upon my data right now. So you can do things like that as well. You can just sort of go in and say, all right, I know what my data is. Now, my painful story is the fact that I ran something like this because I had a table, I had a database. It was one table. I swear it had to be an Excel spreadsheet. Maybe it was an Access application. Notice I didn't say Access database. So, one table. This database was approaching 1 terabyte, and I looked at it and I said, wow, how do I have one table database of 1 terabyte? This seems really weird. So I went and I looked at the columns and I saw datetime defined. And that was my first thing. I go, okay, datetime, let me look at the range. Hey, do you guys really need datetime? No, we probably don't. Oh, okay, all right, hold on a second. So I go in, I look at a few things. Hey, I can save us 300 gigs in space right now just by altering some columns, right? And what I got back was, one, the developer going, I don't want to make any code changes. Because the testing involved, we don't want to make any code changes. Okay, so 300 gigs, and I'm thinking tape backups that now run longer than a day. I'm thinking everything. I'm thinking, how fast are your queries running? You know what? And then my boss going, hey, is anybody even complaining about this? I'm like, no, actually, nobody's complaining about it at all, but as the DBA, these are the things I do. I improve things before they become problems, right? Well, if nobody's complaining about it, maybe you could work on something else. But nobody's complaining about anything right now. Well, then things are good, right? I'm like, no. So I went out of my way, I spent the time, I figured this all out, I came up and I said, I can save us a lot here. I can reduce waste. And they were like, yeah, but it's really just not a problem. Oh, all right, sorry. I thought I was being useful. So don't be discouraged, but if that happens to you, just understand that some people just won't get it. You're, as a data professional, you understand the value of these things. Try to put together a good use case and just say, hey, I can improve performance, we can save space on disk, memory, this, that, and the other, right? But putting together code like that certainly is possible. And let's see, I'll finish up. Code updating architecture. I have these listed last because they are usually the things you cannot do. Anybody here administer SharePoint? Anybody here have SharePoint in their environment? Yeah, you can't touch that thing, right? No, you touch it, you break it, you buy it, right? You can't, at least Dynamics lets you update indexes, which was nice of them. SharePoint, you can't even do that. You just can't touch anything inside SharePoint. So as a result, you can't update code. You can with SharePoint, you can try to update the architecture, scale out. You can have a SharePoint admin go in and make changes through SharePoint to try to help things be a little bit better. But as DBAs, a lot of times updating the code and architecture is kind of out of your domain. You're probably not racking servers and building out networks and things of that nature. You probably don't have a lot of influence in the architecture. You're probably not going to have a lot of influence in changing code on the fly to make things better. You've got to insert yourself in the conversations early on and give guidance about better design, better architecture. So you've got to understand cost, benefit, risk. Say, all right, I see where you're going here, but you've got this table with 10 columns that are all nvar chart 50. If that's legit, great, not a problem. if it's not, let's take 5 minutes now to figure out what those columns should be before we get down to a place where performance is bad and you need that pickup truck to be a Ferrari. So, if you're seeing the signs, you may want to consider updating code. Some frameworks not optimal. We talked about some of those already. And scaling out the architecture, you may need to create a real reporting solution. If you have this mixed-use database, you might be at the point where you simply suggest to them and say, look, performance is bad, and part of the reason is because you're trying to get two things out of this. You need a pickup truck. We may need to scale out. So popular one these days, availability groups. So using always-on technology in order to create an availability group to get that replica that you use for reporting. That's certainly a popular option these days that a lot of people are exploring. So you may be able to get some influence there as well, right? So my 10 steps for right-sizing your data. The takeaway for you to have. Understanding the storage requirements for every data type you consider, we just mentioned that. So you're sitting there, you're in the initial conversations for a design of some type of new system. You say, all right, everybody here understand what you're talking about. You really need date time? Because small date time looks like it's good to me. That's 8 bytes versus 4. This is what it's going to cost us in terms of disk and memory and all that.
So,
Yes, sir.
so I saw actually in a real life experience, and some DBA or maybe some database designer, let's say, maybe that's in Oracle case, they use a new number, right? So you define a float. You may want to precision with a 12 with a 6, but they just say, oh, I don't care, let's throw a number there.
Right.
So that's probably the case like this.
So it becomes numeric 38 too.
I don't know, it's just a number.
Yeah.
Number is basic by default, it's got to be more. Right? I don't know how.
And there are defaults for float as well. So if you don't define precision and scale, SQL Server chooses some for you by
I know.
default. Yeah.
But you don't know, right?
Right.
They give you too large for you, right? And you're not.
Do you need float? Do you need money? Do you need decimal? Right.
Exactly.
Which one is it?
Yeah.
Review all your design decisions based upon the shape of the data, but not just where it is now, but where it's likely to be later. So somebody might look at you and say, you know what, we're fine right now. Yeah, we're fine today. We have 1,000 rows. But where we're going to be in a year, what you're expecting is, we're going to be in something much bigger, and this is going to become unwieldy quickly. So set data types based on business requirements, not your tool defaults. Don't let Visual Studio decide that everything's an integer for you, right? Don't just let the tools tell you and prompt you. Have an understanding. Measure and monitor to fit the data to its data types. So the example I give there is the identity column, right? And you can run your script and just periodically check and say, you told me you were going to be needing this data type, and here we are a year later, and you haven't done it yet. Review each index creation request to see if it's a duplicate. Anybody here actually have code reviews? Yeah. Karen, you don't even work. She just goes to like NASA tweet ups. She doesn't have a job. Where are you doing code reviews? On the plane? Okay. So what I would tell you is that in my environment, we had change control, right? But change control for us was simply here, just go and run that stuff and deploy it. It would have been really easy for me way back when to simply review a few things and say, okay, I see alter or create index in here 10 times. And I see the definition. Do you know you're creating an index that's essentially the same as this other index? Can you tell me why? If you could just spend 2 minutes asking those questions, you can avoid a lot of issues later on. Measure for unused and duplicate indexes regularly. Review new store procedures to verify if parameters are matching. A little bit more in depth for you, but honestly, if you want to avoid some pain later on, you could actually spend the time during the change control to do this as well. I tell you, it's quite valuable. You're passing in an integer, but it's really a bar chart. You're going to end up with an implicit conversion here. Matter of fact, did you run this in test? Because I'm sure you did. You'd be able to find those plans in the cache inside of test, and then you can show them flat out and say, this is what I'm talking about, these implicit conversions. And test only has 1,000 rows. When we go to prob with 1,000,000 rows, this is what the effects are going to be. Find your longest running and most often used queries, right? Because those are probably the ones, if they're running the longest, they probably have a performance problem. Say, hey, get this query. It's running really long, and by the way, these are the reasons why. And a lot of them are design aspect related, and I think we can fix it and we can improve performance there. Look for implicit conversions in your plan cache, we just talked about, and remember that size matters. I don't care what they told you in college. So summary, we said, what's the problem, why data types matter, solution options, and for more information, oh God, what are these for? I think this is a link, so everything's a tinyurl.com. So SQL data types, I think, is a list of all the actual data types defined by SQL Server. So books online link for you. Implicit columns and plan cache. I think that's a link out to Greg Fritchie's blog. I think he had a nice little script that can help you go right into the plan cache and pull out the plans that have implicit conversions inside. Data access performance. This is Bob Boschman's blog that explains the troubles with ADO.NET 3.5, what plan cache bloat is, why it's a problem for you. So if you need information, that gentleman needed. I have a link for that. Then there's a link for row compression, so you can understand more about how that works inside of SQL Server. And another good question about the inserts. I'm pretty sure the page is done after. The page has to get full, like you said. Because you can't, what would you compress before that? Right. And we are done on time, 92.